I will tell you the truth directly because at 95 years old, I have no patience left for fashionable nutrition arguments. The real question is not whether plant protein or animal protein sounds better in a debate. The real question is whether plant-based protein can truly perform the same biological work inside the human body as animal protein. Can it build muscle? Can it repair tissue? Can it nourish the cells with the essential amino acids they require? In other words, can it be just as effective? I have spent nearly a century watching dietary trends rise and fall. In my youth, people believed meat was the only real protein. Later, entire generations began claiming that plants could replace everything animals provide. And somewhere between those two extremes, the truth quietly waited for anyone patient enough to examine the science. Protein is not simply a number on a nutrition label. It is a complex structure made of amino acids, and the human body depends on these amino acids to rebuild muscle fibers, maintain organs, support immune cells, and regulate countless biochemical processes. If a protein source cannot supply the right amino acids in the right amounts, the body must work harder to compensate. So when we ask whether plant protein is as effective as animal protein, we are really asking a biological question. We are asking how these proteins behave once they enter the human body. We are asking how well they are digested, how completely their amino acids are absorbed, and how efficiently they stimulate muscle protein synthesis. This is not a philosophical discussion about diets. It is a scientific comparison of function. And after living long enough to see decades of research unfold, I can tell you something important. The answer is more nuanced than either side of the debate wants to admit. If you want to understand whether plant protein can truly match animal protein, you must begin where all protein discussions should begin, with amino acids. Protein is not a single substance. It is a chain of smaller molecules called amino acids, and the human body depends on 20 of them to function properly. 11 of these amino acids the body can produce on its own, but 9 are different. They are called essential amino acids because the body cannot manufacture them. We must obtain them from food. These essential amino acids are the true reason protein matters. Every time your body repairs muscle fibers, rebuilds enzymes, replaces damaged cells, or produces hormones, it draws from this amino acid pool. Without enough essential amino acids, the body simply cannot perform these tasks efficiently. This is where the first major difference between plant protein and animal protein appears. Most animal proteins contain all 9 essential amino acids in proportions that closely match what the human body requires. Eggs, fish, dairy, poultry, and meat all provide what scientists call complete proteins. Their amino acid profiles are balanced in a way that strongly supports muscle protein synthesis and tissue repair. Many plant proteins, however, contain lower levels of one or more essential amino acids. For example, grains tend to be low in leucine, while legumes may contain less methionine. This does not mean plant protein is useless. Far from it. But it does mean that individual plant foods often provide incomplete amino acid profiles when eaten alone. For decades, this led scientists to assume that plant protein was inherently inferior. But research continued, and over time, a more accurate picture emerged. When different plant foods are combined, such as beans with rice, lentils with grains, or hummus with whole wheat bread, their amino acid profiles complement one another. The leucine in legumes balances the methionine in grains. Together, they form a complete amino acid pattern capable of supporting the body's needs. In other words, plant proteins can absolutely provide all essential amino acids when consumed in variety. But the story does not end there. The second factor scientists examine is digestibility. Not all proteins are absorbed by the body with the same efficiency. Some proteins pass through the digestive system with portions left unused. To measure this, researchers developed scoring systems such as the Protein Digestibility Corrected Amino Acid Score, often called PDCAAS, and the more recent Digestible Indispensable Amino Acid Score, known as DIAAS. These metrics evaluate two critical variables: the amino acid composition of a protein and how effectively the human digestive system can absorb those amino acids. Animal proteins generally score very high on these scales. Eggs, milk, and whey protein often reach the top of the chart, meaning their amino acids are highly digestible and easily utilized by the body. Many plant proteins score slightly lower. This is partly due to fiber and natural compounds in plants that can slow digestion or reduce amino acid absorption. It is also related to the structural differences between plant and animal proteins at the molecular level. But here again, the gap is often smaller than people assume. Modern research shows that when plant proteins are consumed in sufficient quantity and variety, the body can still obtain the amino acids it needs. The difference is often a matter of efficiency per gram rather than an absolute inability to support biological function. Let me explain it in simpler terms. Imagine two fuels that power the same engine. One fuel burns very efficiently, producing maximum energy from a small amount. The other fuel also powers the engine, but you may need slightly more of it to reach the same output. That is roughly how plant and animal proteins compare. Animal protein tends to stimulate muscle protein synthesis more rapidly because of its higher leucine content. Leucine is one of the essential amino acids, and it acts almost like a biochemical signal that tells muscle cells to begin rebuilding and growing. Plant proteins usually contain less leucine per gram. As a result, larger servings may be required to trigger the same muscle-building response. This becomes especially important for athletes or aging adults who are trying to preserve muscle mass. But again, this does not mean plant protein cannot support muscle health. Studies comparing plant-based athletes and omnivorous athletes show that when total protein intake is adequate, both groups can maintain strength and muscle mass. The key factor is not necessarily the source of protein, but the total intake and amino acid balance across the entire diet. Another issue often discussed is recovery. After physical activity, muscle fibers develop microscopic damage that must be repaired. Amino acids are the building blocks used to rebuild those fibers stronger than before. Animal proteins tend to provide rapid amino acid delivery to the bloodstream, which can accelerate the recovery process immediately after exercise. Plant proteins may digest slightly more slowly, but over the course of a day, the body still receives the necessary building materials. What truly matters is consistency of intake. Now let us step beyond muscles for a moment, because protein is not only about strength, it also plays a role in long-term health. Large epidemiological studies have observed interesting patterns. Diets rich in plant protein are often associated with lower rates of certain chronic diseases, including cardiovascular disease and metabolic disorders. But this does not mean the protein itself is solely responsible. Plant-based diets often come with additional benefits: higher fiber intake, more antioxidants, lower saturated fat, and greater diversity of micronutrients. These factors work together to support overall health. Animal proteins, on the other hand, can provide highly concentrated sources of essential nutrients such as vitamin B12, heme-iron, zinc, and certain bioactive peptides that support immune and metabolic function. So once again, the comparison becomes more complex. We are not simply comparing two proteins. We are comparing two nutritional ecosystems. And after watching this debate unfold for decades, I have learned something important. The body is remarkably adaptable. Human physiology evolved in environments where food sources varied widely. Some populations relied heavily on animal foods. Others survived primarily on grains, legumes, and plants. Both groups produced healthy individuals capable of strength, endurance, and long lives. Which brings us back to the original question: is plant protein as effective as animal protein? The answer cannot be reduced to a slogan. Plant protein can absolutely support the body's biological functions when the diet is well planned and diverse. But gram for gram, certain animal proteins often provide a more concentrated and rapidly usable amino acid profile. Effectiveness, therefore, is not a simple yes or no. It depends on how the proteins are consumed, how much is eaten, and how the entire diet is structured. And that is where the real wisdom begins. Now let us move deeper into the heart of the question, because effectiveness is not only about amino acids on paper. It is about how the body responds over time. I have watched this conversation evolve across decades of nutritional science, and the truth is that the human body does not respond to protein in isolation. It responds to patterns of intake, patterns of digestion, patterns of metabolism that unfold day after day, year after year. When scientists evaluate protein effectiveness, one of the most important measurements they study is something called muscle protein synthesis. This is the process through which the body repairs and builds muscle tissue. It is essential not only for athletes, but for every human being, especially as we grow older. You see, after the age of about 30, muscle mass naturally begins to decline. This gradual loss of muscle is known as sarcopenia, and it accelerates with age. For someone who reaches 95 years old, maintaining muscle is not a cosmetic concern. It is the difference between independence and frailty. Protein intake plays a central role in slowing this process. Animal proteins tend to stimulate muscle protein synthesis more strongly per serving because they contain higher levels of leucine, the amino acid that acts as a signal to activate muscle-building pathways. When leucine levels in the bloodstream reach a certain threshold, The body essentially receives the message: repair and rebuild muscle. This is why proteins like eggs, dairy, fish, and meat often produce a rapid spike in amino acids after digestion. The body absorbs them quickly, and the muscle-building process begins. Plant proteins, on average, contain less leucine per gram. They also tend to digest more slowly due to fiber and plant cell structures that must be broken down in the digestive tract. But slower digestion is not necessarily a disadvantage. In fact, slower digestion can create a more gradual release of amino acids into the bloodstream. Instead of a sharp spike followed by a drop, the body may receive a steady supply of building blocks over time. This difference has led scientists to conduct numerous studies comparing plant-based diets and omnivorous diets in terms of muscle strength, athletic performance, and recovery. And the results are quite revealing. When total daily protein intake is sufficient, and when plant proteins are consumed from diverse sources, many studies find no significant difference in long-term muscle outcomes between plant-based and animal-based diets. Athletes who follow well-planned plant-based diets can build muscle, recover from training, and maintain strength just as effectively as those who consume animal protein. The key phrase here is well planned, because plant proteins often contain slightly lower concentrations of certain essential amino acids. Individuals who rely primarily on plant foods may need to consume slightly larger total amounts of protein to achieve the same physiological effect. In other words, the body may require a little more fuel to generate the same level of muscle protein synthesis. But when that requirement is met, the biological machinery functions just fine. Now let us talk about digestibility, because this is another important factor in the effectiveness of protein. The digestive system must break down protein into amino acids before the body can use them. Different foods vary in how easily this process occurs. Animal proteins tend to be highly digestible because their structure is similar to human tissue. The digestive enzymes in the stomach and small intestine can break them down efficiently. Plant proteins sometimes come packaged with natural compounds called anti-nutrients, such as phytates or tannins. These compounds can interfere slightly with the absorption of certain nutrients, including amino acids and minerals. But traditional food preparation methods, such as soaking, fermenting, sprouting, and cooking, greatly reduce these compounds. This is something our ancestors understood long before modern laboratories existed. Lentils were soaked, grains were fermented into breads, beans were cooked slowly for hours. These practices improved both digestibility and nutritional availability. Modern nutrition science has confirmed what traditional cultures already knew. Properly prepared plant foods can be highly nutritious and well absorbed by the body. Another fascinating area of research involves the gut microbiome. Inside the human digestive tract lives an entire ecosystem of microorganisms, trillions of bacteria that influence metabolism, immune function, and even mood. Plant-based diets tend to provide more fiber, which serves as fuel for beneficial gut bacteria. These bacteria produce compounds called short-chain fatty acids, which support intestinal health, regulate inflammation, and influence metabolic processes throughout the body. In contrast, diets extremely high in certain animal proteins, especially processed meats, have been associated in some studies with increased levels of metabolites that may contribute to inflammation or cardiovascular risk. But once again, context matters. Lean animal proteins such as fish, eggs, and yogurt can be part of very healthy diets. At the same time, plant-based diets rich in legumes, nuts, seeds, and whole grains can also support excellent metabolic health. So the conversation becomes less about choosing sides and more about understanding balance. One of the most interesting observations in longevity research is that many of the world's longest living populations consume moderate amounts of protein, often from mixed sources. In some regions, beans and lentils provide the majority of protein. In others, small portions of fish, dairy, or eggs are included regularly. Rarely do we see extreme dietary patterns dominating populations that live long, healthy lives. Instead, we see diversity, and diversity appears to be one of the great strengths of the human nutritional system. Our bodies evolved to thrive on a wide range of foods, as long as those foods provide the essential building blocks of life. Which brings us again to the central question, effectiveness. If you measure effectiveness strictly by amino acid density per gram, animal proteins often come out ahead. If you measure effectiveness by long-term health outcomes within balanced diets, plant proteins perform remarkably well. And if you examine human history, you discover something even more important. Both types of protein have supported strong, healthy populations when consumed wisely. After 95 years of watching people chase perfect diets, I have learned that the body rarely demands perfection. What it demands is adequacy, balance, and consistency. And those principles matter far more than the argument over which protein wins a scientific debate. After 95 years of living, eating, observing, and listening to the endless debates about food, I have learned something simple that many experts forget. The body does not care about ideology, it cares about biology. So let us return to the question that started this entire discussion. Is plant-based protein as effective as animal-based protein? If we speak strictly in biochemical terms, animal proteins usually provide a more concentrated package of essential amino acids. They contain higher levels of leucine, they digest efficiently, and gram for gram, they tend to stimulate muscle protein synthesis more quickly. In that narrow sense, animal protein often holds a slight advantage, but biology rarely exists in narrow definitions. Plant proteins, when consumed in sufficient amounts and combined across a diverse diet, beans with grains, lentils with vegetables, nuts with seeds, can provide every essential amino acid the human body needs. They can support muscle repair, maintain metabolic function, and sustain long-term health. The difference is not that plant proteins fail to work. The difference is that they sometimes require more thoughtful composition and slightly greater total intake. And that is the truth many people resist hearing. Effectiveness depends on context. A balanced plant-based diet can absolutely nourish the human body. A balanced diet that includes animal protein can also do the same. What matters most is the overall nutritional pattern, not the rigid label attached to it. At my age, I no longer look for perfect foods. I look for patterns that sustain strength, clarity, and vitality. And the greatest lesson I have learned about nutrition is this: the body thrives not on extremes, but on intelligent balance.